Okay, we're back. So here's the graphing calculator, and here's the Y1. You should have typed the function into this area. If we go ahead and hit graph, and you might need to play with the window a little bit, you'll see that the graph here is representing this function that, by the way, what kind of function should this be? I mean, we're talking polynomials. What's the type? Is it constant? Is it linear? Quadratic? Cubic? Quartic? What is it? What type is it? Well, if you'll notice, every one of the variables, where x is the height here in this case, has an exponent of 1 because we haven't multiplied all these pieces out, these binomials out to you. So, but if we do, we're going to have to multiply x to an x, that's x squared, and then another x, and that's going to be x to the third. This is a cubic function. Now let me think back to geometry. When you did volume and you calculated the types of units, your units were cubed, third degree, right? Because you had 3 dimensions. So the polynomial is a cubic function that models the volume of space, 3 dimensions. Isn't that a nice coinky-dink? I think so too. And so that happens to be a cubic. So the function itself, if you graph with the right window, we've learned that cubic functions have this kind of in behavior, one's up, one's down, all the things we learned about that. And then we've also learned we've got maximum and minimum points. But what I want us to talk about is the reality of what the situation is. And in this domain, this is where the volume is positive. But in this domain, this is where the heights are possible. Remember, if the width was 21.6 centimeters wide, that material that we started with, this domain, I wonder why it crosses 0 here. That's a 0. Let's go and calculate that 0 in that position, like we knew how, like we learned how in a previous lesson. That 0 here is going to be 10.8. Notice that 10.8 is half of the width of that paper. That means that if we cut 10.8 height off of each corner, you're not going to have any paper left to have a box. So the volume that it would hold would be non-existent. And then it gets negative. We don't understand volume that's negative. Again, this axis is modeling the volume. This axis is modeling the height you're cutting off of the corners of your material to fold up and create that box. So what we want to focus on is this domain, where the heights are from here to here, and seeing where we'd get the most volume. Well, here's where we'd get the most volume. That's the max, right? So we can use our calculator then to do work for us and calculate the maximum. Doing it in the same way we've learned in previous lessons. Telling the computer what is that interval that you want me to calculate the maximum point for. I'm not teaching you how to do that in this video because we've learned it in a previous one. And calculating that maximum, it tells us that h, or x, or the height, needs to be around 4 centimeters to get this maximum volume of 1,088 cubic centimeters of popcorn. That's the biggest box. That's the box that will hold the biggest amount of popcorn than any other volume, any other dimension. And I want to demonstrate this real quick. I'm going to hit the trace key, and you watch as the height changes that we're cutting off on the corners. You watch what happens to the volume. So let's get less than 4. See how the volume is getting smaller? The amount of popcorn it holds gets smaller. But as the volume gets closer to 4, then it gets to be the biggest, and then let's make the height bigger. Let's go to 6 and do 6.3. Notice how the volume is getting smaller as it keeps going on. So that's how we can use the algebra. This is the algebra that models it. This is the geometry that models it. And that's how we can use mathematics to design with precision things like maximizing a volume of a rectangular popcorn box so that, you know what? I can get more popcorn in my box than you because I know the math. And you can guess, and it'll take you forever, but by the time you get it figured out, I'll have done used algebra already really quick, and I'd have all the popcorn eaten. That's algebra. We are the Ask Academy.